Continuing with probability, example A, we want to find the complement of P of A. Which is 1 minus P of A. And done. Example B is also using the complement to find the probability. First, let's label A equals having red/green color blindness. Now we can use this to find the probability of not having red/green color blindness. Next, we look at probability using a contingency table. This is for cases where there are more than one way to classify the data. Like in this example, we have information on male and female drivers as well as brands of cars. Here we want the probability that a male driver is selected, which will be 90 out of 165. Example B, we want the probability that the driver drives an SUV, which will be 40 out of 165. Example C, we want to know the probability of selecting a male driver or an SUV driver. Using the addition rule here, we do need to take away the overlap of male drivers and SUV drivers. Simplifying everything, we get 110 out of 165. Example D, we want the probability of a convertible or an SUV driver. Using the addition rule again, in this example, we have no overlap. Now we introduce some basics for the multiplication rule. Recall the addition rule and probability of A and B. In this case, this means A occurs and B occurs at the same trial and in the same trial. Probability of A and B can also mean that A happened first, B happened next. To determine the meaning of P of A and B, you will need to be clear on the context of the problem. The multiplication rule allows us to calculate the probability of multiple events with the knowledge that the first event occurred. A and B are independent if the occurrence of one does not affect the probability of the other. Events that are not independent are called dependent events. Here is a quick example of independent events on tossing a coin twice. Since these are independent events, we can look at the probability of heads and then heads again. We do this using multiplication. Now look at an example with rolling a die twice, which are also independent events. Here we can show the probability of getting a 6 and then a 6 again using multiplication. So it looks like for independent events that P of A and B will equal P of A times P of B. Now another example where we look at without replacement. Here we are drawing 2 cards from a deck of cards. So for the first draw, the sample space is 52 cards. And the sample space on the second draw is 51 cards. So calculating the probability, we take the change in sample space into account and multiply as follows. Formally, we call this conditional probability. P of B slash A means probability of B given that A has already happened. If events are independent, P of B slash A is equal to P of B. If events are dependent, then we do need to adjust. Now let's do some examples using conditional probability. Example A, we want the probability of a male driver selected given that an SUV driver has already been selected. And our result is 20 out of 40. Example B reads the probability of a truck driver given a female driver has already been selected. So the result will be 15 out of 75. Example C reads probability of a female driver given that a truck driver has already been selected. So the result is 15 out of 60. Example D reads probability of selecting a female driver and then selecting an SUV driver. Notice if we read it as probability of female and SUV driver, we get 20 out of 165. Now let's rewrite it using the multiplication rule. Now we find P of F, which is 75 out of 165. Let's create a little more space here. Now we find probability of SUV driver given that female driver has already been picked. Which is 20 out of 75. And voila, we get 20 out of 165, which we already knew. Example E, we want to find probability of selecting a convertible driver and then a female driver. Now rewrite using the multiplication rule. Probability of a convertible driver is 15 out of 165. And then probability of female driver, given a convertible driver has already been selected, which is 10 out of 15. If calculations are very cumbersome and if a sample size is no more than 5% of the size of the population, treat the selection as being independent, even if the selections are made without replacement. In this example, we want to find the probability that 30 chips selected are all good and not defective. If we do this treating it as dependent, which it is, it becomes a real hassle to calculate. But since 30 out of 10,000 is less than 5%, we could pretend these events are independent, which makes the calculation much easier. Some cool things with complements. At least one is equivalent to one or more. The complement of getting at least one item of a particular type is that you get no items of that type. This is useful especially since doing it without the complement would result in calculating p of 1 plus p of 2 plus ... Here are some examples of describing complements. In this example, we are looking at multiple choice questions, each with 5 possible answers. We want to find the probability of getting at least one correct answer. Not really easy to calculate this. May be easier to use the complement. The complement of A is finding no correct answers. Finding the probability of no correct answers is 4 out of 5 times 4 out of 5 times 4 out of 5 times 4 out of 5. Using the complement, we know P of A is equal to 1 minus P of not A. And so the probability of getting at least one correct is 0.5904.